2 centuries ago, probably 80% of us worked on a farm. A century ago, probably 40% of us worked on a farm. Today, 2% of Americans work on a farm. Did we become obsolete? No. We just found other things to do.
Most robotics demos never ship. Deployed is about the ones that do. This is Deployed, where physical AI gets real. Awesome, Alfred. It's so great to be doing this conversation.
Thanks for having me on your show, your podcast.
Yeah. This is super exciting. I mean,
is this the first time you have a guest, or because it's usually just you? What's on your mind?
Yeah, that's right. I've been doing my own kind of weekly videos and doing that as a podcast, and so now we're trying to bring some folks together, and really right now, like folks that I've worked with and known a long time, and obviously we've worked together maybe more years than we want to admit, but
all the way back at Tell Me Networks.
Tell Me Networks, and you joined in 99, 2000?
99, 2000.
I want to talk about AI, right?
Yeah.
I think physical AI, in particular, robotics. Obviously your background as both, Tell Me was an early AI company, so I want to kind of go back to like some of the things we maybe learned there and lessons from that, but also, operating at Zappos, operating at Amazon, and then, moving over to the investment world, DoorDash. Like you've seen this kind of scale and growth and what it takes to apply technology into new operational domains at scale. So I really want to kind of tap into that today. But yeah, maybe give me a little bit your journey and maybe kind of with an AI focus. I mean, people probably heard your story, but give the kind of your touch points with AI and where you started to get some of that experience.
I mean, maybe start with a line from one of my partners, Constantine, that AI is kind of a misnomer. In some sense, we've been working on AI since the 1950s when Alan Turing came up with the Turing test. And things that seem magical for a period of time was what AI was. So there's a time when people thought just being able to do sort of the level of computation was magical. Then there was user interfaces, that was magical. Then there was, all right, well, that's not that magical. Like, how do you do something that's natural language processing? So when we met at Tell Me, the frontier of AI was speech recognition. And Tell Me did put servers in the cloud, you helped design the architecture for basically putting servers in the cloud. We had to rack them. We had to build our own data centers.
Yep. There's no one else's cloud to use. Yep.
There's no one else's cloud to use. And we answered 800 numbers and we automated them. So a lot of what over the years have seen like AI, whether it's voice recognition, machine learning, natural language processing, computer vision, we don't call that AI anymore. It's like we just keep moving
Yes.
the goalposts of what really AI is. And now we're in the world of large language models, and those things are magical. And so now we're thinking, okay, well, what's AGI? And AGI in the digital world is not AGI in the physical world. But I go back to, our time at Tell Me, and that was pretty magical to be able to automate. Where we started, it was 20% of calls just by changing the UI and asking a question or two to narrow down a listing for 1-800-555-1212, which is like 800 directory. And it was just information. All we did was like, instead of saying, how can I help you? What's your listing? Here's your number. We said city and state and then the listing, and then that sort of narrowed things down. So some of the AI was just purely asking the question the right way, and then obviously recognizing what you were saying, adjusting for accents, things like that, that over the years, we just don't think that's AI anymore.
Well, what I remember with Tell Me, Tell Me was really this application layer of speech recognition, right?
Yeah.
Was how important it was to build trust, right? If you wanted to automate, so like one of the things that we became insistent on, and our voice design team became insistent on, was that you be able to get to an agent, right? Because if you could get to an agent easily, then you were much more willing to trust the automation system and give it a chance. I know I'm curious how you think now about kind of trust and AI and how we're doing it, kind of building that trust with customers and really how that's going to play into, obviously at Cobot, we think a lot about trustworthiness in the experience of interacting with robots.
I think in every generation of technology, there's a scareness factor. Like, what does this thing do? Is it actually going to be helpful? Sometimes the technology is a little kludgy. It doesn't do everything. And trust has always been an issue to get right with technology. And if the companies that sort of think about trust and figuring out the human in the loop element, what makes you trust this new technology, it's really, really important to sort of just make sure that that is done properly. And so today, when we started looking at just digital AI, it was all about human in the loop and making sure there are no hallucinations. And if there were hallucinations, how do we suppress them and give feedback into the system that this is a hallucination? Back then, in voice recognition, if you couldn't do it quickly enough, you passed it on to an agent. And that was important because you knew that it was going to get solved in a short period of time. It wasn't just going to think in an infinite loop and you're going to be in that loop 5 minutes later and not get your answer. And, when we left Tell Me, you went to Amazon and I went to Zappos. And one of the things that we needed to do was to do automation because picking, packing took a lot of time and processing returns. There's a very human element to it. But moving shelves from point A to point B versus a human going point A to point B, that was pretty interesting of a problem. And so we found this company called Kiva Systems and we implemented Kiva Systems. We needed to have a place where there'd be trust because we're moving a whole shelf from one point to another. And it was interacting with humans. Humans will walk alongside Kiva moving around. And eventually we figured out, okay, well, that can run at a certain speed. Can we run this where no humans are in around a certain space? Can we run it a little faster? And eventually humans stopped going from point A to point B. They were just moving the shelf from wherever it was to the human. That was an element of developing trust over time. And then the magical thing about the intelligence of machine learning there is like you move the inventory around in sort of logical ways that you move the slower moving things to the back of the distribution center and you move the things that are moving very, very quickly to the front of the distribution center. It's just this natural flow that happened. And then the other thing I would say about whether it's digital AI or physical AI, the human in the loop element to fix problems, because exception handling is incredibly important, whether it was at Tell Me Networks or at Kiva Systems, and where you're doing now at Cobot, when something doesn't go perfectly, how do you handle that exception? When some of the best companies, when something goes wrong, it's their way to recover. And in some ways, when we see something that doesn't work, as a consumer, we're a little disappointed. But when we see the company or the technology or the combination of human and technology and the company fixing the problem, you turn someone who may have just ended up being a detractor into an immense promoter if you're able to correct that problem quickly.
Just to add more to that story, obviously, for folks who may not know. So Amazon acquired Kiva Systems in 2012. And then when I took on robotics at Amazon in 2017, that team, the Kiva was now Amazon Robotics, Boston-based team, and we scaled that from about 50,000 robots to 500,000 robots in 5 years. Amazon's over 1 million robots now. But you were telling me that
it almost didn't happen.
Yeah. So tell a little bit more of that story.
Well, so Amazon acquired Zappos in 2009. And during the due diligence process, we showed the team at Amazon how we ran operations. And they were a little surprised at how low our cost per transaction or per order was. And like, how are you doing this? And we showed them that we were using all this automation. We wrote our own warehouse management system. We wrote a lot of the back end. We were routing people and Kiva in very efficient ways. And what I was told is our cost per order was lower than that of an Amazon fulfillment order. And part of that is because we were only processing shoes and handbags and clothing, much simpler orders. But they were very surprised, and they're like, "Oh, what else are you using?" And we showed them that we're using Kiva systems. And I think the team and Jeff Volke was like, "This will never work at Amazon." Part of it is because Zappos' spike in the holiday season is like 4 times that of the regular rest of the year. But Amazon's spike in the holiday season is like 25 times or 50 times. You can't have 25 to 50 times more robots during that time. So I was like, all right, whatever. It's not my problem. You guys figure it out. they they saw how we operated. They took some of the robots and put them in other places. I heard that they were being used for Amazon Fresh for a period of time. And then a few years later, Amazon showed up to Kiva Systems and bought them for $800 million because they wanted Kiva to only produce robots for Amazon. And you were put in charge because you were a distinguished engineer that's built much of Amazon's retail systems. And you were so good at it that they put you in charge of scaling the robotics team. And you became VP of robotics for Amazon. So that was an amazing run for you.
Yeah, I mean, my experience at Amazon was really, really incredible. Really fortunate to, I mean, the scale and the expansion. Now, I want to take a slight detour because we've been talking about. So I started my career at Netscape. Netscape was acquired by AOL.
Yeah.
Tell Me was acquired by Microsoft. Zappos was acquired by Amazon. Kiva was acquired by Amazon. Then I was at Scale AI, recently acquired by Meta. How, as an investor, how do you think about acquisitions and the return? And because everyone's always focused on the IPO, the kind of, and yet a lot of companies we've worked for end up, selling over time. Like, how do you view that as success, failure, middle? Like, how do you think about it?
Maybe this is a non-answer. I don't really think about exits as an investor. I never really thought about exits when I was an employee of those companies that eventually exited. I think what you want as an investor, or you want as an employee, is a founder that you trust, and you want a founder with big dreams. And so, sure, like when you start out on day one, you're not building the company to be acquired. I don't think any of us would join a company that was just meant to flip. I don't think we would join you want to invest in a company or join a company that's just like, okay, if it hits my threshold of a price, I'm just going to sell the company. Mm-hmm. That's not the ambition.
Right.
And keep in mind, in this day and age, and even back then, you get a high-paying job in technology. Why take a pay cut and join a startup unless you really believe in the mission? And so most of the time, what we're looking for as an investor are founders that want to put a dent in the universe. Our mission at Sequoia, very clear. It's been the same mission, is to help the daring build legendary companies. We're not helping the daring build a company to flip. We're not helping, sort of those who want to buy low and sell high. And so I don't see it as a success or failure. It is just the path. And some people find that it's much easier to sell a company because they realize the market is too small. They realize that and so that's perfectly fine. We took a risk. My job is to take risks. Founders' jobs to take risk. The risk doesn't always work out, and it's perfectly fine to sell the company if you realize this is not working the way I thought. Sometimes you sell the company because you realize that the acquirer can take it to another scale. I would say that's probably true with a variety of companies. Like WhatsApp was taken to another scale at at Meta. Instagram was taken to another scale at Meta, and
YouTube and Google. Yep.
YouTube and Google. Your experience with Kiva. I don't think Kiva had more than $8 million. It was acquired for 800 million. I think it was somewhere between $8 and $11 million of revenue at the time.
Yeah.
But it didn't have the scale that Amazon eventually scaled it to because of you. You scaled it to millions of robots. And so the impact that a platform can have on your company, your idea, your product can be immense. And yeah, sometimes you go all the way and you take the company public, and it's extremely rewarding either way, because you're on a mission. You try to change the world, and that's why it's fun. So now you went to Amazon, you went to scale. Now you've started Cobalt. You're trying to take all of your learnings from all these different places, from Netscape to Tellme to Scale, and you bring it to Cobalt because you understand software, you understand operations, you understand AI, and you understand robotics. And that's why it's a rare combination. Often we're looking for founders who have problem market fit. And so you have founder problem fit here, you have founder market fit here. It's really interesting to have you lead a robotics company because you bring all these different disciplines and combine them and bring them to work.
When I think robotics is such a complicated space, right? Because you're bringing AI, you're bringing software, you're bringing hardware, you're bringing operations together in a system, right? And when I think about, that kind of application layer of physical AI, right? How are we going to bring physical AI into the real world? It's, in some ways, like what Cursor did with bringing coding models was they built a whole scaffolding around the developer experience and workflow. And it's amazing. To do that in robotics, there's so much more complexity you have to bring in order to transform a hospital operation or a warehouse. I want to come back to physical AI, but one thing I want to touch on before we get there. So fascinating kind of thing that I remember from Tellme was that, Moore's Law, right? And, Sequoia famously invested maybe the first or an early check in NVIDIA, right? And now we're watching that scale. What I remember at Tellme was, every couple of years we got faster, we call them rec machines, speech recognition machines, right? And I suspect you were signing off on a lot of those, investments. What it allowed us to do, and this is kind of a subtlety of the algorithm at time, the kind of Gaussian mixture models, to your point earlier, we had to return the speech recognition result quickly, right? Which means we had to do the computation or the inference. Now, I don't think we use the term inference as much back then, but inference on the model. And in order to do that quickly, there was a pruning function in the algorithm. The Viterbi search would prune branches that were less likely. And what we found, every time we got new speech recognition machines, we could turn down the pruning, which meant we could explore the model space more completely, and the speech recognition got better every time. And I think about that now with inference and with compute and how parallel we're searching the model space, and just how like Moore's Law has really enabled that, and how much now we've gone back to kind of optimizing software all the way down to the GPU layer. I don't know. I'm curious what you're seeing. Obviously, there are new chips. The Grok acquisition by NVIDIA recently. Do you think this Moore's Law keeps playing out this way, and we keep going through these cycles, or just AI is driving something completely new?
I think maybe the other way to look at this is like when something works, you just keep pushing it. And sometimes it requires someone on the outside to push things that other people don't believe. So Intel pushed Moore's law, and NVIDIA pushed something different, which is not the CPU but the GPU. And in whatever case in technology, you are always trying to figure out more efficient ways of computing, more efficient ways of sending data from point A to point B, more efficient ways of processing. It's not just compute that you need faster and faster and faster. You need disk to go faster and faster. You need input output to go faster and faster. And it requires a lot of people who find these technologies fascinating to keep building and building and building. I mean, I don't know. I don't remember how many times you had to re-architect the Tell Me system, how many times you had to re-architect the Kiva system, how many times you had to re-architect the hardware so that it can operate faster or cheaper. Better, faster, cheaper is the advantage of technology. And Silicon Valley is basically built on that. Cost advantages, speed advantages. And, it is fascinating to me that technology makes things cheaper and more powerful at the same time. The laptop that you and I carry is cheaper today than the laptop I got when I was the first laptop I got when I was at work, like my first job. I don't know how many times more powerful, and yet it costs less. And technology is a great deflationary thing, and it just makes all of us much more productive and much more efficient, and it lowers the cost of doing business.
Yeah, I was thinking about this recently. I think Jensen did those of us in robotics a huge favor about a year and a half ago when you put that chart up that showed, language models, agentic AI, and physical AI as the
Yeah.
because what it did is it caused a lot of really top AI scientists, ML engineers to see that problem and want to go after it, right? And, what I'm really excited about is, 18 months later, we're now seeing some of the research papers. We're seeing the diversity of kind of work in world models, in VLAs, in reinforcement learning. Obviously, we have our own thesis as kind of what some of the critical problems are in physical AI. But I'm curious kind of what you're excited about, what you're seeing, and how maybe you think this plays out.
Well, I think that maybe I'll just pop up a level. Robotics, in my view, robotics has existed for a long period of time. We just don't necessarily call it robotics. Just like AI, we just keep moving the post. Humans used to there were scribes. There were people who hand wrote things. And then the printing press happened. We don't call that a robot, but it is basically a robot. The printing press is a robot. All the books that we, sort of publish now is basically produced by robots. Newspapers are produced by robots. We just don't call that a robot anymore because
Right.
it's just
Your
so
office
simple.
printer
Your
is a
office
very
printer,
complicated robot.
It's
Yeah.
it's a much more complicated robot than the printing press. And I think if you think about every single appliance that we have, a human used to do that job, and now it's called an appliance. And there are simple appliances like a coffee maker. And sometimes you want specialty coffee. You want a person to hand drip the coffee because we like that. But coffee makers, they're good coffee makers. They do the job just fine. And we don't call that a robot. Your washing machine, your drying machine, you know how many hours we would have spent washing clothes? And probably we didn't spend that many hours because we only had 1 or 2 changes of clothes. But that's like a pretty sophisticated robot. Humans used to wash these things. The one thing I would say about all of those appliances is that they do the same thing over and over again. Kiva does the same thing over and over again. It's a very, very specialized robot. It can route. It has intelligence because it knows how to pick a specific route, make it faster. That's software. But it basically is doing the same thing over and over and over again. I think lots of people are asking, what's the ChatGPT moment for robotics? I think we have it. It's called the autonomous car. It can navigate into much more flexible environments. Yes, it's doing the same thing over and over again. It's driving you from point A to point B, but it's navigating you through all sorts of new environments that it hadn't seen before. And I think that's very, very exciting. So robotics used to be hand-coded lines of code on how it does something over and over again. And now with large language models and these agentic abilities, it's able to learn in new environments. I think what's going to be fascinating is the flexibility of robots in the future.
One of the things it's rare that I'm like surprised by robotics, right? I've been around robotics, I've been deploying robotics. But we did this hackathon combining our robot capability with the Hippocratic AI, and so we got together with both teams, and the team built a fall detection model, right? It was a multimodal model that would watch and notice that someone fell and kind of intervene and say, "Are you okay?" Right? And so when the end of the hackathon, the team went to present this, and the developer fell, right? Kind of faked the fall, right? And then the robot said, "Hey, it seems like you've fallen. Are you okay?" Right? And the guy, acting, right, kind of moaned, was like, "Oh," and the whole audience cracked up, right? And the robot paused, and it said, "I think I know what's going on here. It seems like you've fallen, but I hear laughter in the background. And so I think you're okay." Which was just shocking because, there's a lot of capability, obviously, in these large language models and these multimodal models. And we talk to them and they seem very intelligent, right? But then when you put that into we're used to talking to something like Alexa, which has very constrained, and at Tell Me, obviously, we were kind of in a very constrained speech recognition space. With these models now, where they can pick up that situational understanding, I think as we bring more and more of this kind of, I think when we talk about physical AI, a lot of us are thinking more about dexterous manipulation, but I think we're not always looking at the perception capability and the intelligence and the interactivity that these robots are going to have, which is going to make it very different than your office printer. And to your point, very different than a task-specific robot. I'm really bullish that we're going to have these kind of domain-optimized robots that are great for hospitals, but can do lots of tasks in a hospital. And I think that's obviously the thesis behind Cobot.
Flexibility in robotics is going to be a game changer. Because having a robot bring, I don't know, bedding from one side, from the laundry to each bed and have someone pull it out, that kind of saves you a little bit of time. But then you can bring drugs, and then you can bring food, and then you can deliver whatever, reading material. Like when you can have that many use cases, it just makes sense to have more robotics around. And I think most people think that form factor is going to be a humanoid. It may be something completely different because there are more efficient ways than having a humanoid.
Yeah, I mean, I think it's going to make sense to optimize a bit for the domain, right? In that, in environments where floors are flat and you can use wheels and be stable, like it's going to make sense to do that.
Yeah, you can move a lot faster.
Yeah, and if you're going to, operate underwater, you wouldn't use a humanoid, right? It's kind of obvious. But that doesn't mean you're not going to want manipulators to be able to, do various work under the ocean, right?
Yeah, there's a line that has gone viral, which is the humanoids are going to win because the world is made for humans. And I remind people that the world is quite hostile to humans. So yes, the environments we've created for ourselves. And maybe in an office environment, you want humanoids, and maybe in your home, you may want that, maybe not. But I don't know, the ocean is not made for humans. Space is not made for humans. And so There are a lot of places in the world that the humanoid form factor doesn't quite make sense.
Well, and we've really built a lot of the world for throughput, for, in these industrial world, how do we get things done quickly, which isn't always the best environment for humans.
Yeah. Well, a highway is made for cars.
Exactly.
For throughput,
Exactly.
to your point, it can go faster by putting a car that can go 50, 60, 80 miles an hour, and humans cannot go that fast.
Yeah, I mean, hospitals are designed around the ability to move wheelchairs and beds around, right? And so there's a lot of structure to the world that you can optimize. Well, let's think a little bit about, obviously our question at Amazon as we brought more automation in was, are we going to displace jobs? And we didn't. We kept growing. I'm curious how you think about both AI and physical AI and robotics and the kind of workforce transformation that we're likely to go through.
I recently put a post out called Farmer to Banker. It was about a lot of concerns around AI and jobs. And, there's just a lot of dystopian conversations around AI. And yeah, there'll probably be some disruption to jobs. Every single technology has faced that, whether it's the printing press or electricity or the steam engine. And I just remind people that those who fight technology have been on the wrong side of history. And yes, I'm a venture capitalist, I'm optimistic, but history is pretty clear on that. And the reason that that's true is technology is applied knowledge. We create these things because they're tools that help us. And whether it was creating a tool to help us fish or hunt or to not write and be a scribe. And so then there's only a limited number of people that can read or write because there are not enough books to go around the world. I mean, think about that. We thought it was great that there was a certain class of people who were educated. We never thought about educating everyone. And now that we have everybody who can basically read and write simplified languages so that there are a lot of alphabets that got simplified over time. Languages got simplified. That's a great thing for literacy. And it's kind of personal to me that technology basically unlocks human potential. My father grew up in a farming village. He was destined to be a farmer, and he was very fascinated by the abacus. So he became good at it. He was a high school champion in abacus. And because he was that good on basically being a human calculator, he got a job at a bank being a bank teller. And he, because of that, he could save up money, go to college. He put 3 sisters through college. Of course, since he was working in a bank and he was a teller, he looked at all the smart people who were in the accounting departments. And so he studied accounting. He studied accounting and he rose through the bank. And as he sort of saw that the abacus was replaced by calculators and calculators were replaced by computers, he came to the US and studied computer science and got his master's in computer science, went back to the bank and revolutionized the accounting department. And then eventually he ran the bank. And so, someone who was destined to be a farmer became a calculator, became a programmer, became an accountant, became a programmer, became the president of a bank. That's unlocking human potential. And so I go back to two centuries ago. Probably 80% of us worked on a farm. A century ago, probably 40% of us worked on a farm. Today, 2% of Americans work on a farm. Did we become obsolete? No. We just found other things to do. Basically, farm automation freed 98% of us not having to grow our own food to feed ourselves. It's amazing. And the other thing that, so yes, we needed to find jobs for farmers, but we did. We found other things for all of us to do. And My father showed me a spreadsheet once, and he basically says this is no different than the and rows and columns of desks in an accounting department. He used to be at one of those desks, and he's replaced by a cell in a spreadsheet. He wasn't reminiscing about the good old days that he was sitting in front of a desk and all he was doing was calculating things and balancing a general ledger. Not the general ledger, just the chart of accounts. The general ledger gets balanced because you got computer systems that are balancing the debits and credits and everything like that. Anyway, so I just think that we're going to find ways to unleash human potential with digital AI and with physical AI. What's more fascinating to me about physical AI and just AI in general is that if you look at the world's GDP, it's about 110 trillion. Over 50% of that is labor. And there's a lot of labor that will not go away because we want the human care and human touch and the human connection. And there's just some stuff that moving boxes from point A to point B, is that really a great job?
Yeah, I think about, I mean, I grew up in rural upstate New York. I grew up in farm country, right? My neighbors, kind of the kids on the school bus were dairy farmers, right? And they were up at 4 a.m. They were like, that's tough work. But one of the things I remember is, the dairy farmers, that there was a lot of consolidation in the 80s, 90s. The ones that were successful were the ones who were sophisticated about applying capital to buying technology, whether it's automated milking machines or, a new tractor, and we're sophisticated about the payback period on that, the labor cost reduction. It wasn't about, oh, this is cool or exciting. It was about, okay, I can farm these many acres, have this many head of dairy cattle, produce this amount of milk, right? And it was always fascinating that the most successful farmers had to become, very smart technology adopters and capital allocators. And I think that's, as we take a lot of the manual work out, we often become creators, right? We become entrepreneurs. We become, sophisticated about, hey, if I apply these resources this way, I can achieve this kind of. I've looked at that kind of agrarian transformation. The other one that I've looked at it a lot that was quite interesting is in 1958 the patent came out for the pin setter for bowling. And before that, there were people whose job it was to reset the pins in between frames. And it was a bit of a dangerous job because you had to pay attention because balls are rolling towards you and pins are flying. But what happened is when the pin setter came out, those jobs did go away. But the game experience got better, right?
Yep.
The pin setting was faster. There was some automated scoring, like a lot of the game got better. And the proliferation of bowling alleys, right? In the 60s, it became a kind of social phenomenon because the cost structure got low enough that the game experience got good enough that everyone started doing it. And then there were more bowling alley operators. There were more, construction crews setting it up. There were more cleaners. There were more. And so actually there was, the whole economy. And I think Jensen talks about this, as we get more technology and productivity improves, new jobs do get created and we float to those jobs. And to your point, throughout history, that's been true.
Well, as an example, spreadsheets actually increased the number of finance professionals because you didn't actually have to be as good at arithmetic because you can rely on the spreadsheet to do the arithmetic for you. So it's more about logic and thinking through what you are trying to do with the spreadsheet, not about actually making the calculation. So I'm very optimistic we'll find more. Some jobs will get displaced, but we'll find other callings. And for me, my challenge to all founders and entrepreneurs is, okay, if AI is that powerful, if physical AI is going to be that powerful, what major problems are we going to solve for society, for humanity? And if you solve that, that's okay. Some things will get disrupted, but we'll find other quests and other callings and other things to do.
So I was catching up with Jeff Wilke recently.
Yeah, how is he doing?
He's doing well. I think both.
Did you go see him in where? LA, Seattle?
When was the last time I just caught up with him on Zoom recently?
Oh,
But
okay.
so I mean, you and I both had the chance to work with and for Jeff at Amazon, and Jeff's a chemical engineer by training. I was giving him a hard time for like his whole thought process resolves around the closed loop control diagram. But he thinks a lot about bottlenecks, right? He thinks forward about
Yep.
bottlenecks, and it's kind of his manufacturing background. I'm curious. I mean, obviously, bottlenecks are good opportunities for investment. So I'm sure you and Sequoia think a lot about kind of bottlenecks and what's emerging. Where do you see maybe the bottlenecks that are, there's the obvious ones: data center power, GPUs, but are there other bottlenecks you're interested in right now, kind of exploring?
I'm not sure I think about the problem as bottlenecks, whereas I think about the problem as what just doesn't, which is a form of bottleneck, is like, why do we do this? It's maybe more of a sociology element.
Mm-hmm.
I understand that cooking is sometimes fun, but it's not always fun. Why can't we get all like food delivered to you? Like, yes, there's a bottleneck, like getting the food made and then delivering it to you. Yes, that's a bottleneck. And so someone has to solve the operational problem of the bottleneck. But I probably think about the consumer experience slightly differently. So every single technology transformation has been a combination of hardware and software. And we haven't really had a hardware change for a long period of time. So I think about that. So in the world of AI, what is the change? Consumer hardware that's going to need to get produced for it to be an interesting combination. I mean, when we had mobile, obviously it was both the smartphone and also the apps that were built on top of it. For the internet, there wasn't really that much of a hardware change, but there was a move to the cloud. There wasn't a hardware change required for the consumer, but a lot of things got put in the cloud. And, my partner Pat had all these like sort of technology waves. AI could not have happened before the internet happened and all the data that we were willing to put in the cloud happened, because it made it a lot easier for these large language models to crawl all this information that exists on the web. And so AI is currently being powered by GPUs, which you could say is a hardware differentiation, and it's in the cloud. But on the consumer side, what's changed? Not much. And so, quite interested in that.
When you think about physical AI and kind of how we get to, I think your point that autonomous vehicles are a powerful form of physical AI. They've shown an ability to generalize, at least within kind of the scope of some major cities. When you think about the space of dexterous manipulation and how we get that kind of physical AI, are there things you're excited about there, techniques that you or do you, like you just described with bottlenecks, do you think about it in a different way?
Yeah, I think so back to generalization. I think LMs have shown tremendous ability to generalize, and that has been applied to a bunch of breakthroughs related to autonomous vehicles has been its ability to generalize. Dexterous manipulation is fascinating to me because we're kind of still using like the hand as the most dexterous form, and we're teaching robots how a hand works. Maybe that's the right form factor. I'm guessing that's probably not going to be the right form factor. And so there's a lot of like work related to dexterous manipulation by having humans teach a robot what a human would do. I'm going to be fascinated when the robot teaches the robot the
Mm.
ways that it can do things that a human cannot do, because a human wrist doesn't turn all the way 360 degrees like a robotic wrist can turn. Or forget about the human, the hand and human like nature. What is the new form factor that makes it interesting? I mean, at Amazon, you're probably not picking things up with claws. Suction works just fine.
Yeah, I mean, two interesting stories there. I mean, one, Amazon, we did the picking challenge, right? And it spurred a number of research teams and ultimately a bunch of startups, including Covariant, which Amazon ultimately acquired, to go after this challenge of picking things from bins. And that was just like a singulation task, right? Just pick one at a time, right? The other challenge is how do you sort it, right? Pick it and place it into one of a number of. Um, so yes, it turns out like the number one most successful thing to improving the pick eligibility from kind of the low 80% to the low 90%, so the biggest kind of 10% delta is pretty big, was to increase the suction power of your suction gripper, right? Just a stronger vacuum meant you could pick up some things that
That's
you otherwise
heavier
couldn't
that
get a
you couldn't
grip
get
on.
on.
Exactly. Or like a pen, if there's even though you couldn't get a full grip on it, there was enough air flowing around it, you still got enough suction, right? But also Amazon, obviously a lot of work in this kind of like sortation, but we were able to use a mail sorter, right? This mail sorter that had like a little internal cart, right? And I would call it an iBot, but it was inside a cage, and the bot would just move around, and actually it's super capacitor, so it would just pick up charge as it went, and we could just flow a conveyor onto one of these little shuttle carts, and then the shuttle would go to one of a destination, and then a little conveyor belt on the shuttle would kick it in, and we could sort hundreds of items. The rate was way faster than human and way faster than what we could do with a picking arm. And so I think it is the case that sometimes there are better mechanisms, right? And I think about suction as it would be great if we had little suction capabilities on our hands. So much things would be much easier to pick up if we weren't. And so I think, that's the exciting, I think hardware and AI evolve together. And to your point, if we get the kind of physical AI where we can discover new things, where we can play, then to your point, you can add another joint, or you can wouldn't it be great if we had two opposable thumbs, right? And instead of trying to learn from kind of a human analog, we can learn by playing in the world like kids do. That's what I'm really excited about with physical AI. And I think I'm also excited that if we can solve that type of play, you think about trying to learn the world's knowledge that LLMs have been able to interpret. Like, it takes us as humans 20 plus years to like gain a lot of that knowledge. We have to read a lot of books. We have to consume a lot of information. We figure out how to manipulate things in the world
Very quickly.
in 2 to 4 years, right? And so I think we're missing some of the techniques right now, but that's the exciting thing, is there's so many researchers working on it right now, and I'm starting to see really interesting kind of novel approaches that maybe we won't have to do what we did and suck down the whole internet's worth of text in order to learn. Maybe we will be able to learn and bootstrap the way we do as humans and just get better at things. And then to your point, we won't need to be constrained to the morphology of a human hand or arm.
Yep. It's exciting times.
Exciting times, exciting times. Well, this was terrific. Thank you so much for taking the time. And yeah, I look forward to our next board meeting.
Thank you for having me on the show. I look forward to the next board meeting as well, where I'll be asking you all the questions.
Awesome.
All right,
Thank you,
take
Alfred.
care. Bye.